Hey, it's Mr. Pielsa with Precal. This is Unit 4, Topic 2, Parametric Equations. This is the first lesson. We're starting off with the warm-up here, given the following characteristics, the following vectors. So we're given the magnitude is 17 and the direction is 200 degrees. Now, as we did in the last topic, we know that that would be magnitude times cosine of the angle, comma, magnitude times sine of the angle. Sine is always the height, cosine is always the distance, distance across. So simply put that into my calculator, make sure I'm in degrees. So 17 times cosine of 200 gives me roughly negative 15.974. And I'm going to then do 17 times sine of 200. And that's going to give me a negative 5.814. Now, this is a 200 degree angle, which just take note the fact that 200 degrees is going to be in the third quadrant, and the fact that it's a negative means that's in the third quadrant, so that does make sense. All right, so for this question, this is going to also be in the third quadrant. Now, the first thing I'm going to do is I'm going to figure out the angle. This is 50 degrees. I know 180 degrees is halfway around, so 180 plus 50 gives me 230 degrees. So this is 230 degree angle, so therefore it's going to be magnitude times cosine of 230 and then 12 times sine of 230. All right, so put that in my calculator, times cosine of 230, and that gives me negative 7.713, and 12 times sine of 230 is going to give me about negative 9.193. All right, starting right into it. So parametric equations are basically when you have multiple equations, kind of like system of equations, but you have two equations that happen to represent two different parameters. Hence, parametric comes from the word parameter. The first one is going to be the parameter of the horizontal component. This is all projectile motion. Now, keep in mind, parametric equations could just be any equations that represents two different parameters. But in this case, for projectile motion, which is what we're going to use it for, these kind of questions, the horizontal component, which means how far an object travels, the distance it travels, whereas this is going to represent the height of that object as it travels. So we're going to use both of these equations, and we're going to write a set of parametric equations. Now, this is, once again, this is the formula for projectile motion. It's pretty commonly used, but it's not always going to be these equations for all parametric equations, just for all the questions that we're going to do for this video. The left field fence at 400 feet from home plate is 8 feet high. A baseball is hit from 2 feet high with an initial velocity of 150 feet per second. And an angle that's 25 degrees with the horizontal. Now, when you're looking at this, v of 0 means the velocity of the object at 0 amount of time. Cosine of the angle just means the angle in which it's going towards, and t represents the amount of time. Same thing here, and h of 0 means, or h sub 0 I should say, just represents the height of the object at the beginning, which would be after 0 amount of time. So x is going to be equal to, so that's going to be the velocity, which is 150 feet per second times cosine of the angle times t amount of time. Then for the height, that's going to be represented by negative 16t squared. It's always going to be that, plus 150 times sine of 25. So notice that this parenthesis and this parenthesis are basically the same. Just distance is cosine and height is sine. That kind of makes sense. And then multiplied by t amount of time, plus you have to also add the starting height, which in this case was 2. Because you don't hit a baseball off the ground, you actually hit it off of, either off of a tee or in the air. In this case, 2 feet off the ground in the air. Is the hit a home run? So I need to figure out, well, how much time does it take for it to reach 400 feet? So if I put 400 in for x, and I can then solve for t. And the way I'm going to do that is because this is being multiplied by t, I'm going to divide both sides by cosine of 25. So divide this by 150 cosine of 25. This cancels out. So when you're putting this in the calculator, just make sure that you put this in parentheses. Otherwise, you're going to get a wrong answer, basically. 400 divided by 15 times cosine of 25. Please also take note of the fact that I'm pressing parentheses twice. Once because to end this parenthesis, but then also again once because I need to end this parenthesis. Then press enter, and it's going to give you an answer of 5. Okay, so that cannot be correct. Oh, I did multiplication. Okay, so obviously I forgot to press divide by parenthesis 15 cosine of 25 and parenthesis. All right, so let me show you again. That's actually the correct way of doing it. And that's going to tell me that t is about 29 seconds, and that does not feel right either. Oh, it's 150. Okay, so one last try. 400 divided by parenthesis 150 cosine of 25. So obviously, making these small errors, it's important for you to take note of the fact that you need to understand why you're doing something, when you're doing something, that whether or not your answer is reasonable. And that's the reason why I knew those answers didn't really make sense, because they weren't really within reason. Because there's no way a baseball is going to be in the air that long. So it's really 2.94 seconds. Now that I know how long it takes the ball to travel from here to here, it takes 2.94 seconds. Now I can put that in for t and figure out the height of the baseball at that exact moment. So that's negative 16 times 2.94 squared plus, all right, let me move myself. So that's 150 sine of 25 times 2.94 plus the 2 at the end. All right, so now the nice thing is I can just put all this in the calculator and press enter. And then that'll give me my height. So that's negative 16 parenthesis 2.94. And once I'm done putting this in, I will once again show you. And I only put it there for a split second because I know it's a video. And you can, of course, always pause it to see what I've put in my calculator. Sine of 25. In parentheses, I got to press double parentheses again because sine of 25, it's kind of like this. I got to double parentheses it. And then 2.94, and then add 2. All right, so now showing you exactly what I put in, and then I press enter, and it looks like it's going to be about 50.07 feet. Now, I go back to the original question. It says the height of the wall is 8 feet tall. So is that going to be a home run? The answer is yes, because 50 is greater than 8. So obviously it's going to be higher than the wall, so therefore it is going to go into the stands. All right, so now obviously I'm not going to have enough time to do all of them, but I would like to do at least one more. I'm 8 minutes in, and my limit is at 15 minutes. An arrow is shot from a bow 4 feet above the ground. All right, and it's at an angle of 10 degrees with a horizontal velocity of 250 feet per second. All right, so that's x equals, so that would be parenthesis, velocity is 250 times cosine of the angle, and then times t amount of time. So y is equal to negative 16t squared plus parenthesis 250 times sine of 10 times t plus the starting height, which was 4 feet. All right, find the amount of time that it'll take for the arrow to be in the air. Now, there's multiple ways of doing this question. If I'm talking about height of the arrow, then I want to use this parameter. This happens to be the parameter for the height of the arrow. So what I'm going to do is I'm going to put that equation in my calculator for y equals like this, and that's what you can just see what I'm doing right now. X squared plus parenthesis 250 times sine of 10 parenthesis times x. Now, keep in mind, I'm using x to represent the t for time, but that's what it looks like when I'm done putting it into the calculator. Now, what I'm going to do is I'm going to press graph, and it's not going to show you the entire graph. You can see it looks like this. Okay, so you can see that it's going up and then it's coming back down. So what I'm looking for is I'm looking for that point right there in which it hits the x-axis, because that's the amount of time it took for it to have a height of 0. Once the object is, the arrow in this case, is hit the ground, obviously it has a height of 0. So what I'm going to do is I'm going to press second calculate. which gives me this screen. I'm going to press number 1 I'm sorry, no, I'm going to try that again. I want to press number 2 for 0 because I want to find where it hits the x-axis. And then it's going to ask you a series of 3 questions. It's going to say left bound, right bound, and guess. Now, if you notice, and I can hold this up here, that this little blinky cursor right there is on the left side of the answer, so I'm going to press enter. And then that blinky cursor is still there. So what I'm going to do is I'm going to press the right cursor button, and then I'm going to keep pressing it, and the cursor does disappear. But I kept pressing the right cursor button until my cursor is now down here. So then I can press enter again. I press enter one more time for guess, and then it's going to give you a screen that looks like this. And that's going to give you your answer of about 2.8 seconds. Give or take. Find the horizontal distance that arrow travels before it hits the ground. Okay, so now all I got to do is put my 2.8 for t and solve, because this is the parameter for distance traveled. Cosine of 10 times 2.8 seconds. I can just go to the regular screen for that. So parenthesis 250 times cosine of 10 and parenthesis twice, and then times 2.8 seconds. All right, so that tells me that x is going to travel about 689.37 feet. All right, what is the maximum height of the arrow? Okay, so I'm going to go back to calculate, second trace again. But this time I'm going to put number 4 for maximum height. And it's going to ask you basically the exact same 4 questions. Right now my cursor is on the right side of the maximum height. Keep in mind, the maximum height is off the screen. The maximum height is all the way up here because the graph, it goes up and then comes back down. So I'm going to move it over here to the left-hand side by pressing the left cursor button. And if you never see the cursor, that's fine. I actually end up seeing it at 0.4. But once you get into like negative, once you're x, because it tells you the x and the y at the bottom left-hand corner, if you look down here. Once you're at a negative x, then you know you're at negative time, and you know you're on the left side of the graph. And then I'm going to press the right a bunch of times. And once again, if you just press it 10 times, you'll probably see it. But if you don't ever see it, and let's say I've passed it now, and I'm going to press it a bunch more times. I pressed it until I got past the 4 seconds, which is the x, and I know I'm looking at the graph that the answer is between 2 and 3. So therefore, I know I'm past it on the right-hand side. So I'm going to press enter and enter again. And it's going to tell me the maximum height. Now, it does take a bit of time for this to happen. It's going to give you this information right here. Now, basically what you're looking at is it's telling you that x is 1.35 seconds. That's how long it takes in order to reach its maximum height. And to have a maximum height of 33.44 feet. Now, to quickly talk about this, and I know I'm running low on time, a lot of you might think that, hey, I can just divide this in half. Since the graph basically looks like this, right, that I can say that if this is 2.8 seconds, and then halfway is when it's going to reach its maximum height, and that would be 1.4 seconds. But once again, look at the calculator. It says it doesn't reach its height at 1.4 seconds. There's a reason for that, because this is not a quadratic graph. This is actually a trigonometric graph with cosine or sine involved. Well, actually sine, because we're talking about height. So it's not really a perfect parabola. So therefore, you can't, you can kind of assume that's going to be pretty close to 1.4, but it's actually 1.35 seconds, because an object is going to go much faster in the beginning than it's going to be at the end, which is causing the reason why the maximum height is not at. But if you put 1.4 into the value, so if you go second calculate and put in a value of 1.4, yeah, you're going to get an answer that's pretty close to the maximum, but it's going to say 33.4, which is very close to 33.44, but not quite the maximum. All right, and that's it for me, and please give it a like that helped you learn something about parametric equations, and look forward to the next video. Thanks again for watching. Have a wonderful day.